This is a demo for the if else and if else if structures in Java. Remember we had the stacked if structure before, which includes 4 if statements. Each is checking for a certain condition or range of a MAC number. Notice here that if you check if MAC is greater than 5 and then you find it to be hypersonic, you will go and continue and ask all of these questions all the way until you finish the code. Now, there is the if else structure, which if we want to limit that or keep that classification simple, I could ask if MAC is greater than 5, it's hypersonic, or I could, for example, make it greater than 1, and then I say it's hypersonic or supersonic. And then I could go and say in the else clause of that if statement, and notice here that with the auto indentation, Java is going to align this else with that if. In the else clause, I'm going to say system.out.println, and here I'm just going to assume it's very simple. I'm going to ignore the transonic state, and I'm just going to call it subsonic. So again, with auto indentation, notice here that this is all a single block of if statement. So the else is part of that if. It's matched to that if. So if MAC is greater than 1, that is a condition which, if satisfied, this will be conditionally executed. If not satisfied, which is the else clause, this is going to be conditionally executed. So here, if I run this and then I try to enter, let's say, I'm going to enter 250, which is subsonic, then it's going to classify this subsonic. So it goes and checks, is MAC greater than 1? Since 250 divided by the 344 is less than 1, this condition is not satisfied. It goes to the else and it executes that part. Now, one way to keep your code simple and easy to read is to enclose all of these in curly braces. So the if clause in a curly braces and the else clause in another pair of curly braces. All right, so that would work and do the same thing. 350, it's going to be hypersonic or supersonic. All right, I'm going to keep this as print, so this way we get the input on the same line. So here 350, so now it's working this way. All right, so let's expand this and try to go and try to make our code more efficient. All right, so remember we had the stacked if statements, right? We said if MAC is greater than 5, that is going to be system.out.println supersonic. All right. So let's go back to our classification and try to make it more efficient. We have seen the classification using the stacked if statements. So if it's greater than 5, it's hypersonic. If it's greater than 1 and less than or equal to 5, it's supersonic. If it's equal to 1, that's transonic. And if it's less than 1, that's subsonic. Now, as we said, we will need to go and check all of these, even though they are mutually exclusive, which means if it's greater than 5, it couldn't be less than 5. It couldn't be equal to 1 or less than 1. So I don't need to ask or check for all of these conditions. So in this case, I can connect all of these statements with the else if phrase. And in this case here, notice how once I add else, it's going to join these two if statements. All right, another else here. Again, that's still part of that big if statement. Then a third one, and that is another part of this if statement. So you will notice here all of this highlighted as a single block. And what's happening is that you check if MAC is greater than 5. If yes, then you execute hypersonic, and what Java does is that it skips all of this and exits that if statement. However, if it's not greater than 5, in this case it will go to the next condition and check, is it greater than 1 and less than or equal to 5? And again, if it's yes, if it's true, then it will execute this and then skip the rest. else it's going to go and check the next condition, which is mac is equal to 1, and so on. All right, so this is one way to classify it. And if we do 350, it's going to be supersonic. If we add 2500, that's hypersonic. And then one thing that I would like to point out here is that there is some redundancy to this code. It's working. However, it's not the most efficient. It's not the best code. The reason is because you have some redundancy here. For example, if you check if mac is greater than 5, so if this is not satisfied, then you will skip this line here, and then you go to the else here. The fact that you reach this else here means it's not greater than 5, which means it must be less than 5. Now, if it's less than 5, then checking for if it's less than or equal to 5 is redundant. You don't need that. All right. So here I could remove this part and I could compile and run. All right. And 2500 would give you hypersonic. However, if I enter 350, it will give you supersonic. Okay. Now, if it's not greater than 5, if it's not greater than 1, then I go and check if it's equal to 1. If it's equal to 1, then it's transonic. If not, then I'm going to go and check if it's less than 1. Now, here is also another redundant part of this code. If it's not greater than 5, if it's not greater than 1 and less than 5, if it's not equal to 1, the only thing left is being less than 1. So if you just add an else condition here, or the else statement here, this is going to capture everything else which is being less than 1. All right, so that is another redundant part of that code. So if I go and run it, and enter 250, it's going to capture this as subsonic. It works. Okay, if I enter 344, oops, that is definitely subsonic. 344 is transonic. So it's capturing all of this correctly, even though I removed the code. Now, one thing very, very important to notice here is that the idea of removing redundant code depends entirely on how you organize your code. So if I go and check for the first thing, if it's greater than 1 and less than or equal to 5 to classify it as supersonic, then I cannot go and say checking for greater than 5 is redundant. So what I'm trying to say is that removing or moving these conditions or the order of these conditions around is going to change what we mean by redundant and not redundant in this condition. All right. So here, for example, if I go and say I would like to check for supersonic first, then supersonic checks for, let's move that here, call this else, and make this the F. Okay. So notice here that if I keep the same structure, if I run this, and let's say I print it to be 2500, which is hypersonic, it's going to be classified as supersonic. Why? Because 2500 is greater than 1. It's going to give a MAC number that is greater than 1, and Java is going to match this to this case, and then it's going to print supersonic and skip the whole structure. You see? So in the first case, in the first scenario, that was okay because checking for greater than 1 came after checking if it's greater than 5. However, here, since greater than 1 comes first, you have to be more specific and ask if it's also less than or equal to 5. So that should fix this problem, because now 2500 is going to give you something that is greater than 5. It's not in that range. Skip this and go and ask, is it greater than 5? Yes, print hypersonic. So that simple change changes the meaning of what is redundant and what is essential.